Okay, we're going to check out our most recent experimental controlled burn here at Briery Creek. These are our 10 meter by 10 meter research plots where we're looking at fixing of organic carbon into black carbon, charcoal, biochar, which will then remain relatively stable in the soil, so it acts as a carbon sink while improving soil biogeochemistry. So we'll get a close look at what the litter looks like after it's been burned. This is successful. You can see the char layer on top. It's a nice black landscape, but the duff layer is intact underneath it. That's what we want. That's kind of the basic rule of thumb in controlled burning. If the landscape is blackened when you're done, then you've had a successful burn. If it's white and gray, then you've consumed all the organic carbon rather than fixing it, and you've done a little bit of damage to the system. If it's kind of yellowish red after you burn, then you've really cooked it hard and done very, very serious damage to the landscape. But the ground here is black, so we certainly met that criteria. We have managed to kill some of the small caliper understory trees. Some of the larger caliper ones are doing just fine. They'll survive this. So we've reduced our stems per acre of understory trees. And of course the loblolly pines are perfectly fine. This is a relatively low intensity fire, burning approximately 15 to 30 centimeters high in terms of flame length. And took it the better part of an hour to travel 10 meters, so this is a very gentle backing fire. The forest here is still closed enough that we're not going to get a whole lot of herbaceous vegetation coming in, so we'd have to thin this out a lot more to get that. Our main purpose with this particular study site is to see how much organic carbon we can fix into black carbon. And we'll do a side-by-side comparison real quick, show you what it looks like just beyond the fire break. So this is what it was like before, just a blanket of pine needles, minimal understory vegetation, a few blueberries, some small oaks, a few yellow poplars here and there. The density of this form of charcoal, the bulk density, is about 0.13 grams per cubic centimeter. So that's about a tenth of the bulk density of good mineral soil with a proper structure. And if you spread that out over an acre, a ton of the material would only be a millimeter thick. So just looking at this casually, you'd realize that there's a millimeter or more on most spots where there was good fuel litter to begin with. So that led to the hypothesis that we can fix a substantial amount of organic carbon into black carbon that'll remain in the soil and in the environment to sequester carbon by doing these controlled burns at a low intensity. And so far that's fairly well confirmed. When we collect our samples and dry them out, weigh them out, we're getting in excess of 1 ton per acre for each of these burns. We're doing it here in this mid-rotation closed loblolly forest as a control, because there's a very much intact litter layer. These trees are 20 years old. They've been depositing litter for 20 years. So we have a good litter layer fuel bed to work with. It's very consistent. So later on we can repeat the study in some of our open savanna landscapes and see how the system works there. So we're trying to figure out how much of this material is laid down, and then also what are the weather and fuel conditions that optimize your charcoal yield. What's the best air temperature? What's the best ambient relative humidity? What do you want your litter moisture to be, and what do you want your duff moisture to be? And do you light a backing fire that has to go against the wind, or a heading fire that goes with the wind? Yeah, those are questions we're trying to answer with this study. What are the best conditions to maximize the amount of carbon that you fix into the environment? Because we know that charcoal has a lot of benefits to the soil. Chemically, biologically, physically, it's a good thing. It's certainly known that the Native Americans burned the landscape on a regular basis, and they certainly left a very rich environment with excellent soils after living here for thousands of years, so we're going to see if we can reproduce that. So there you go. This is burn plot number 10.